This tutorial is for 6th grade, Module 4, Lesson 3. In this lesson, we're going to look at variables and coefficients in expressions. At the top, it says you may have seen these ways to show the missing number in a problem. So we often represent a missing number by an empty box or a question mark, and then more specifically, a letter. When we use a letter to show the missing number, we call that letter a variable. Knowing that, we're going to write some expressions using a variable for the missing number. First one says 7 plus some number. Well, that some number is that unknown number that's going to represent our variable. To write this in number form then, I just need 7 plus some number, and we'll use an x for that some number, that unknown part of the expression. Question B says 10 minus some number. So this time we'll start with a 10 and we'll take away some unknown number, and again we'll use an x in this case for that missing number. Here are some different ways that we can show multiplication. The first one shows 5 times n. We need to get used to seeing that dot in the middle and thinking of it as a multiplication sign. Another way to show multiplication is if we have a number on the outside and then something on the inside parentheses. And in this case, we would read this as 5 times n. And then we also have multiplications shown by that variable and a number right next to the variable. When we write it in this format, the 5 is called the coefficient. It tells me how many times I'm going to multiply the variable by. So again, this means that I would take 5 times n, or whatever that missing number is. So the 5 again is called the coefficient. And I'll write these multiplication expressions using the coefficient and a variable. Question A says 8 times a certain number. So we know the coefficient is going to be 8, and then I can use x as my unknown number. I can use n or any other letter to represent that unknown number as well. Question B says 12 times a certain number. So 12 is the coefficient, and then I have an unknown number that I use an n for in this particular problem. In this section, we see a few different ways we can express a division problem. The first way is probably more traditional in the elementary level. We have 15 divided by some number, or I can reverse that and say I have some number divided by 4. I can also show division in fraction form. When I write it in fraction form, I would read this as 15 divided by n. The last one I would read as n divided by 4. So now I'm going to write these division problems using my variable. So we have 20 divided by a certain number. So I could write it using that traditional division sign. I can also write it in fraction form, 20 divided by some number. Question B says a certain number divided by 3. Here we have some unknown number. I'm going to use an x in this case, and I'm dividing it by 3. To write that in fraction form, the x would be the numerator and the 3 the denominator, and I would read that as x divided by 3. Just as we simplified expressions in the previous lesson, we can simplify expressions when variables are found in the expression as well. Here's a couple of examples. The first one is x plus x plus x. The most compact way to say that is 3 times x, because it's 3 groups of x. So I would write that as 3 being the coefficient and the x as the variable. In the next example, we have n plus 50. The simplified version of this would be 2 times n, so 2 is the coefficient, n is the variable, plus 50. Notice that I do not combine the 50 and the 2n, because those are 2 different terms in this expression, so you wouldn't combine those. Part 4 asks us to now simplify expressions using the variables. Part A says I have 4 groups of x, so I can write that as 4x, meaning 4 times x. Part B shows that we have 5 groups of x, so that would be 5x, and to that I'm going to add 60. Part C is showing the distributive property. So if you remember, the number on the outside tells me what I'm going to multiply everything by on the inside of the parentheses. So 3 times x would be 3 groups of x, or 3x, and to that I'll add 3 times 10, or 30. So that's the simplified version of that distributive property example.